continue plowing through problems in chapter 1 of Anton. Just having a lot of fun. I couldn't wait to do this, and I'm very happy that I'm doing it. As far as the paces by week, I'm in the 4th week of my plan of 31 weeks, but actually I sort of skipped one because I thought it was going to take me longer to do some of these problems, which is great because what I'm doing is I'll continue to get a little ahead, June 12th versus June 21st, and that means that I will be able to squeeze in some reading, although I'm not sure that I'll have to do that much. It won't be reading the way that I had to do an analysis, that's for sure. It's very different. There's a lot of, it's very much example based. Some proofs, which I like, but also just a lot of grunt work, which I'm really enjoying. I think it's at the level that this material is taught, most students who take this class, who use a book like this one, haven't been out of high school for that long. And so I see how Anton is trying to build discipline of understanding where things go. And so it'll be very interesting. There'll be a section that's really easy, like really easy. You can just grind through half the problems from my perspective. But I understand that, there was a point in time, many decades ago, when I was a young engineering student, where I really needed that. I needed somebody to tell me, why don't you put these equations together and read a matrix off of them and do it 10 times in a row. So some of that work is what's happening here. So this is sections 1.5, 1.6, and 1.7. And so this method, which I had learned when I was taking number theory, I don't think I ever had to use this if I did use this in engineering, I've forgotten. I learned it for number theory, where you start with a matrix and you mirror with the unitary matrix, and then every operation that you do here, you also do on the right-hand side until you get the inverse. Now, of course, what I always do when I do these problems is I go back and I multiply the inverse by the original matrix to make sure that I do indeed get the unitary matrix. And so these problems were very interesting. Every now and then, one of them becomes a fraction and a bunch of fractions, and those were very difficult. Just the grind of getting all the right fractions. But I've also started to learn a little bit of a trick of how making sure that I never get to fractions by multiplying by factors instead of using the fractions. And I'll show you an example of that, incredibly enough that I did not need to do, but I did it anyways, and it was fine. Yeah. Then the whole business of symmetric matrices, upper triangular, lower triangular, diagonal. When you multiply them, what happens? All the different theorems of if you multiply two lower triangular ones, you get a lower triangular one, and so on. Yeah, just using symmetric matrices. This was a lot of fun. This was definitely a lot of fun. Then section 1.8, matrix transformations. Am I on that, or is that? No, that's it. That's it. I'm done with that. Sorry. Getting ahead of myself because I've already started working on section 1.8. Actually, that one's actually pretty easy. So, of course, I said that I love the 100-page problem set, but because of the way this book has so much grind, which I love, this is really more going to be like the 200-page problem set because, of course, matrices are just so fat. I've actually had to order more paper than usual because I'm just cranking through sheets and sheets of paper, which is fun. I mean, nothing wrong with that. So let me go to my marker just to show you all the worked out problems. And yes, every now and then I'll screw something up. But most of the time, it's just grinding out the solution, and I'm here to do that. I screwed one up. Otherwise, just a sea of problem solving that I am really enjoying. Every now and then I'll get close, which is good. proofs at the end. There are no answers that I have in the book for most of these, but I can tell more or less that I'm in the ballpark. If I do an empty one, I'm like, nah, I'm not confident that I did it. So the true and false, got a one wrong back there. And I really like doing the true and false. I originally wasn't planning on it, but now in every single section I complete the entire true and false because I am finding them very, very instructive. Highly recommended if you ever use this book to complete all the true and false problems at the end of every section. And of course, I've gotten better at catching where I'm wrong and going through and saying, okay, I got this far. I know it's right up to this point. I've also started manipulating specific rows by themselves to get to the final matrix when they're complicated calculations. And then let me see if once I get to that problem that I wanted to talk about, I'll show it. Yeah, I sort of misunderstood what they were asking for. I tried to focus in some of these problems on whether it was invertible or not, but in reality, that's not the issue. They did give you a matrix that was not invertible. They just wanted you to show that the parameters could be made into equations, and yeah. Got to invert that. Another round of true and false, where I screwed up two of them. I misunderstood a statement. I actually did it correctly as written, but I technically said false. Symmetric matrices, a long proof. Yeah, which I eventually had to tidy up to get right. And then, yeah, this was a good example of when it becomes a fraction. Boy, do they get complicated just getting all those fractions correctly. Symmetric matrices. And then there was this long problem that really wasn't long. Very amusing example of read carefully and don't just jump to conclusions because you're having fun inverting matrices. I went on and on. I had this very complicated matrix that I was trying to invert, and I screwed it up multiple times until I finally got it. Okay, I got it right. And then when I started looking through to write up, to cleanly write the answer, I'm like, wait a minute. The answer to the problem never involved inverting that matrix. So I did a double. So basically, instead of doing, it's LU, two matrices, I actually inverted U, multiplied it by L, and then inverted all of that. And of course, it was a monster, and I'm glad that I did. I really enjoyed it. But why? It was not needed. But at least I did learn a couple of techniques in this one of how when the matrix, when the calculations become fractions, I started seeing fractions everywhere. I was like, oh, this is going to be terrible. Then what I started doing is multiplying instead of dividing. So, and figuring out what is a common factor that is large enough to play with all the numbers without ever getting into fractions. And sure enough, in this particular matrix, which is correct, I worked it and it's correct. It multiplies to 1 when you multiply by the original matrix. If you get it to a factor of 24, everything just works out a lot easier than if you let it become a fraction. And then, of course, after you get your final result, you know you got to put a 1 over 24 in the front. And that's that. Skew symmetric is in the problems, but it is not in the body of the text. And this is something that I have found that I already knew. Here are the true and false from section 1.7. Yeah, and I could have written this proof a lot longer and neater. Should do a better job there. Linear algebra is a lot like chemistry. It reminds me of chemistry. There's just so many terms, so many terms. I think by the time I finish this course, this book, I could probably write down 400 definitions of, like, this is a skew symmetric matrix, this is a symmetric matrix, this is an invertible matrix, this is a transpose, upper triangular, lower triangular, and so on.